Okay, so we begin, or I shouldn't say begin, we'll continue with these mechanisms because apparently I said we were going to push that back to tomorrow. And I like I said, I don't think you could make that up. So the problem that we did not get to was this, and I don't know, it's probably chlorine we're adding. I don't know. And then I think it had nickel chloride. Okay, so we'll cover that one, and then let's do this here. Okay. So with this top one, we had a statement that was written, well, a statement, I don't know if you want to call it that, or, It just had said, if there's something on the ring already, then that determines or directs whatever it is you're reacting that with, where that is going to attach. So with this, we need to know what aniline is, first of all. So we know it's a aromatic. Okay. And then what is attached on that ring? Okay. So we'll just go ahead and put them here. I don't know, I got a little too close there. NH2. That is our aniline. So then as we react, since there's something on here already, you are not beginning in the middle of that chart. Okay? So with this, you might say, well, how would we know where to go if we're not in the middle? Well, when you have something on here already, okay, that is a little different because in the upper left-hand corner, we had said you had these variables. One was X, one was your alkyl derivatives, then we had hydroxy, and then, of course, we had aniline, or was it amino? Amino, okay. I suppose, yeah, you can't have aniline, then you're naming the whole compound. Amino group, and then way at the bottom, I'll just make a little bit of space here so it makes a little more sense. Okay? It might not be this order, but we get the idea because these top four then are what we call directors on there. So when that is already attached to the ring, whatever it is that we're reacting that with, this is going to tell them where to attach. Well, not tell them, but direct them, rather. Okay, so we're still reacting that with our chlorine, and sometimes maybe it makes more sense to you to write it like that because that means the same thing because it's a diatomic molecule. Then as this reaction proceeds, we know that it's going to react because we've got our catalyst, and the NH2 is not going to disappear, but that's where this comes into effect, so we don't need this anymore. So that amino group is going to tell one of those chlorines to attach where. Okay? So then when we say second one, and it doesn't matter which one you choose, if you want to go to the top or to the bottom. When we say top or bottom, we're talking about from that site. So maybe it makes more sense to say left or right. Okay, so we're saying bottom and to the right. That means that a chlorine is going to attach here. Okay, and then we still have our aniline here, or amino group. And then where would our other one attach? There's two different sites you could pick. Okay, not two sites. There's only one site that you could. Straight across. Yes, okay. So when we're saying diagonally, we mean diagonally across like this. And I don't know, some people may choose to write it like that, which I think is kind of silly. But I guess that's when it comes to carbons. If you're doing that, that's probably more accurate. But regardless, it's just a chlorine group, so we put them there. Okay. So when you have something on the ring, that's directing it where to go. And that's why you have that in that upper left-hand corner. Okay. I would like to say that this is pretty straightforward, and I really don't know how to say, well, what confusion would there be with that? Well, if you already know what the directors are and the positions, we'd like to think it's pretty straightforward. Now, as far as why it does that I really couldn't tell you. I mean, I suppose it's because there's some electronegativities in here that would cause it to go in both spots. And I would maybe have the same question that you would, and that would be, if it can attach here or here, why would it go straight across? Okay? And that, I think you could say, is a really good question. And it's something I really can't tell you. It's something more so I'd have to rather show you, because this comes from a different source here. And so what we mean by that is something like this. Nope, not that one. I might have went the wrong way. Oh, yeah, this will work too. Okay. Because what I'm about to show you, does a halogen group have anything in common with the amino group when it comes to attaching molecules on there? It would be different? Oh, because I thought we said yes, it would be, that's how I interpret it. So it wouldn't be any different if this was a halogen instead, okay? Well, then the idea behind that would still be similar. It would be an ortho and para director. So what we mean by that then is this information is based off of this, okay? And this is how we kind of made that chart, okay? Because we have this bromine on here, which means it's going to attach it in an ortho and para position. And that's what it's showing you here. It doesn't tell you why, but it just shows you what's happening here. And it's not the only type of reaction that does that. Methyl groups do that, ethyl groups. So whether it's a halogen or amino group, the pathway is going to be very similar. And that's what this is trying to illustrate right here. Whether it's a halogen or whether it's an amino group, it would still be the same. Okay. All right. And with this author, there's different types of reactions that was placed on your chart. Maybe if you notice below, it had the meta director, which is the only by itself. That's just a nitro group. Okay. So the bottom reaction now, one of the things that I think we want to spend a little bit of time on this. This is a really common molecule to use, toluene, and I'm guessing it's some sort of solvent would be my guess, is why we would use something like that. But what we need to do is, how do you get a methyl group on here? And I think the most common thing to say would be to do this. But you can't do that, okay? Because does something like this exist on its own? And you're shaking your head no, and that would be correct, because if we look at the structural formula then, what we're saying is that, and that can't be right, Okay? We're illustrating a methyl group, that's true, but it's missing an attachment here. So then, when you are looking at your chart, if we're starting here in the middle with benzene, I want to say it's about 730 or so. It's how you get from benzene, and it doesn't say a methyl group up there. It says that. Okay? And R just means this could be a methyl group, it could be an ethyl group, it could be a propyl group. Any alkyl group is what R stands for. So again, it is a variable. So what you would see then is in the middle, and I want to say if this was our benzene ring on your chart, there should be a pattern that's about right here at about 730. Does that sound correct? Okay. So what we have here is right so far, but it doesn't say this. It probably says that. And that just doesn't mean reaction. R is, again, any alkyl group. It could be ethyl chloride, it could be propyl chloride, it could be isobutyl chloride, any one of those. Because, again, what is X? It's a halogen. That's why we say propyl chloride. I mean, that's an alkyl group because that's what you would have. Propyl chloride, 3 carbons, 7 hydrogens, and 1 chlorine. Now, when you do this, it would be really, really easy to do this. And we're telling you that that is wrong. If it was propane, this would be right if it was just propane. So sometimes when we're doing these, there's absolutely nothing wrong with using the structural formula. So how do we know that this one's right and this one's wrong? Well, if we look at the structural formula, okay, we got our 3 carbons, and that is propane. No one would argue with that. But then once you put your chlorine group on here, that is no longer a hydrogen, but rather a chlorine. So then how many hydrogens are on this bottom structure now? There's 7 of them. So that means this can't be right, so it has to be that. So maybe it's one of those aspects until we get really, really comfortable with this, you might not want to write this condensed formula down. Maybe just rather write the structural formula. And there's nothing wrong with that. So and this would be an R and an X because we have an alkyl group and we've got a halogen. So the simplest way to do this, we've got our R group. So then what could we use for X? There's a whole bunch of answers you could use. Use chlorine, fluorine, bromine, any one of those, but we said chlorine first of all. Okay, so now we've got this on here, CH3Cl. Okay, so then this will proceed only, maybe. Does it? Yeah, so you have to have a metal catalyst. Nickel, I suppose, you could use iron. Okay, so now this will proceed. This breaks off. Okay, now we've got our R group attached here, and we can change that to our toluene now. Okay, then if this goes any further, that's where your chart says this splits in half again. This depends upon if you are going to add, let's say, some bromine. Okay, because if we do a metal catalyst again, just say FeBr3, or if we do heat, because that's why you see that splitting up in the bottom. I don't know where you would want to call that, okay? Because if we take the heat portion, okay, you're only going to get one product with that, okay? So we take our toluene, that is still the same, okay? But now this is where you got to be careful. If we are adding heat in this portion, we're not in the center now, we're getting down to the lower left-hand corner perhaps, maybe not quite that far, but if you have an R group or an alkyl group attached to this, you're adding a halogen and heat is your catalyst, how many products do you get? One or two? Just one, okay? So with that, how is this halogen going to attach? Is it going to go somewhere around the ring or somewhere else? What does it say? Because it doesn't say CH here. It probably says R and X. So this is a little redundant, I understand. So this is going to, maybe you could say, come full circle, because R is any alkyl group, X is any halogen. So now we've got R and X. A very simple mistake to do is that right or is that wrong? Not BR2. Is this right? This is not right. That's why this gets to be really, really tricky. Okay? Because what Presley's saying here is if we break this down, this X is right there. And if we say we've got three hydrogens, one, two, three, we've got our four bonds here. There's no room for that bromine. So that's why when you add heat to this, you've got to take a hydrogen off of there and it attaches like this. So that's why we say using the structural formula may be a lot easier to use as opposed to this. This is fine as long as you take a hydrogen off of there. That's the more tricky of the two. Okay? Then if we go through this process, if we decide to add a metal catalyst instead, well then, do we get one product or two? We get two. And it's cut off on your flow chart there, so you have to add that in the lower left-hand corner. So we know we're going to get two products. Okay, so our R group was up top. It'll be the same here. Okay, so where is one attachment for this bromine? Because what type of director is it? Because remember, if there's something on the ring, it's going to direct whatever it is you're adding to that. Okay, so we'll just go ahead and go here to the second one. You can also put it on here. That would be fine. That's an ortho position. And then where is the second one going to attach? On the bottom. And then there is your para position. Okay? So what happens again, when you have something on here, you got to pay attention what type of catalyst are you using. Is it heat or is it a metal catalyst? Okay. Bet you're wishing you were taking the quiz now, weren't you? No, I'm just Okay, that was a lot of information in a short amount of time. You might be looking at this and saying, I don't know if I get it. And then when we're sitting there saying, I don't get it, we might not know what to ask. Because we'd like to think that and hopefully that chart will be be beneficial for you, but maybe not quite yet on our second day of using it. Okay? So that's why, because I don't know if they allow you to use something like this in college or if you just have to remember all of it. That I don't know. That is why when we get to the evaluation, we would like you to try your best to do this without that chart and then move forward with it should you need it. Okay. Whether we're going to do these mechanisms tomorrow, like I thought, as opposed to today, okay, this is probably where we would stop for today.
We could get our worksheet. Yeah, can we get our worksheet?
Oh, I don't have it printed off, but it would not take me very long.
We could just do that since we're supposed to do that on Thursday.
Okay. I will print that off. So I will pause this for just a moment.